So we're going to move on to the other kinds of fish. But before we leave cartilaginous fish, I wanted to remind you of something that they always say about sharks, that a shark has to keep on swimming or else it'll die. Well, that's almost true. Not all sharks swim all the time, but uh, all of the cartilaginous fish have this quality of generally swimming constantly. And the reason they need to do it is because the way they breathe is through gills. And they have not invented a method to pump water across their gills. So they swim to get water constantly moving across their gills. The next group of fish are the osteichthyes, and the osteichthyes are the bony fish. So chondrichthyes, cartilaginous fish, osteichthyes, oste means bone, and then ichthyes means fish. Osteichthyes, they're the bony fish. One of their advancements is that they have got special muscles and a special flap called the operculum that allows them to push water across their gills even if they're holding still in one place. Also, the osteichthyes invented the primordial lung. So let's look at them. We're back here. We've done the sea stars, sea urchins, sand dollars. We did the lancelets and the tunicates. Love the tunicates, those sea squirts, so weird. The hagfish, seriously, make sure you watch that video. It is quite cool, right? And then the lampreys. Lampreys maybe a little less cool. We talked about the sharks, rays, and skates, chondrichthyes. Now we are here, and we are going to group all three of these together in a group that here in Bio 120 we're going to refer to as the osteichthyes. You can see that they actually are a little bit more complicated than one group of osteichthyes. We're going to group them all together in osteichthyes, the bony fish. But we are going to talk about the ray-finned fish. I'm not going to say much about the coelacanths. They're quite neat. They're the beginning of legs, which is neat. And we'll say a little bit about the lungfish, okay? So here's where we are. We're going to group all of these together as the osteichthyes, okay? And we kind of group together the hagfish and the lampreys. Good deal, okay? So here is your basic bony fish. This one that we're looking at here is a ray-finned fish. One of the things they've got is they have got little fins that are moved by muscles. And the sharks, they've got fins on their sides that they kind of use to stabilize them, but they can't move them to like turn themselves around in a tight little corner. But the bony fish can do that. They've got these paired fins that are moved by muscles. And then they've got this thing, the operculum. You probably think all fish have got an operculum, but it's only the bony fish that have the operculum. Everything that we've been talking about before this moment, no operculum. The advancement of the operculum is that a bony fish can just sit still in one place and pump water across its gills and get plenty of oxygen that way. This is how they are breathing. So they don't have to constantly swim. The bony fish also started inventing lungs. And some of the fish that you would recognize as a regular old fish, they actually are pretty good at breathing with little tiny lungs. One example would be, a betta fish. They used to call them Siamese fighting fish, and you can keep them in a very small container. I don't think they're happy there, but you can. And the reason you can is because they breathe by taking little gulps of air from the surface of the water. A goldfish can also breathe that way. But a super advanced kind of fish is known as the lungfish. So many cool things about the lungfish. I can't begin to tell you all of them, but this is what a lungfish can look like. The lungfish, now they don't just have like little ray fins like this guy does. They actually have lobe fins that have got some bones inside of them. This and the coelacanth, this is the beginning of being a creature that has got 4 legs. They don't have 4 legs yet, but instead of having these wussy little ray fin things, they actually have got fins that can drag them across the mud. And they are actually very good at breathing with lungs. They don't need water going across their gills at all in order to breathe. In some places, the ponds and lakes that they live in dry up during the winter, and they put themselves down in the mud in a case of mucus that keeps them moist inside, and they hibernate. And they just breathe air and they hibernate until the water comes back, and then they go swimming around again. So lots of cool things about the lungfish. The lobefin fish, like the lungfish, you can see they've got little bones that are the beginning of limbs, right? And they've got lungs. Now, this early amphibian, this is someone's imagination, or maybe it's from a fossil record. We don't have anything that looks like this still alive today, but the lobefin fish is our connection between amphibians and the first of what are known as the tetrapods. Tetrapods, tetra means 4, and pod means feet, so they've got 4 feet. And the tetrapods are going to start with the amphibians, all right? So a recap, the tunicates, which were so weird, but technically they are chordates. Lancelets almost look fish-like, but no brain, no skull, technically chordates. Now we've got the lampreys. They actually have got a type of vertebra, and they definitely have got a skull, but no jaw. Then the jaw got invented, and we've got real skeletons, but they're made out of cartilage, and we've got the cartilaginous fish. Then we did the bony fish, and we got up to the point of the lungfish. And the lungfish, not quite having legs yet, but kind of a connection there. Now we have got 4 legs, and these are the tetrapods. Tetrapods. All right, so let's see what we can do on the tetrapods. The first of the tetrapods are the amphibians. Here's something weird about the amphibians. The amphibians are animals that go through metamorphosis. Remember, I think it was last week that we talked about how there are insects that go through metamorphosis, like the butterfly or a regular fly, or some beetles. They go through this phase where they're this like grub or caterpillar or something like that. Well, the amphibians also do metamorphosis. So here is an adult frog. This probably eats bugs. Here is a tadpole. Tadpoles live underwater. They don't breathe with lungs, they breathe with gills. And they eat little things that swim in the water, like the larvae of insects. Tadpoles of frogs are really good at eating mosquito larvae, for example, okay? So they actually undergo a metamorphosis. The amphibians, they are the first land vertebrate, but they are very much tied to the water. Most of the amphibians need to be really close to water because they need to keep their skin wet all the time. Most need to keep their skin wet all the time. A lot of them actually breathe through their damp skin. Now, there are amphibians called toads. Toads have a relatively dry skin, but they still are tied to the water because they reproduce in the water, they lay their eggs in the water, and their offspring are larval stages that are doing their metamorphosis thing in the water. So what is the name of a larva of a frog or a toad? A tadpole, right? tadpole. So these are the first animals to live on land. They require fresh water. They don't live in oceans. I don't know why, okay? But they have this mixture of being a little bit aquatic, but also terrestrial, and they usually need water to reproduce. Actually, I don't even know what the exception to that rule is. I got to look that up. We're going to talk next time about something called the amniote egg, but these guys don't have an amniote egg. They've got this bare minimum egg. They lay it in water. The little tiny things that hatch out, they just got to feed themselves because mama ain't going to do it. That allows amphibians to lay, hundreds and hundreds and hundreds of eggs. But every little thing that hatches out has got to feed itself and get itself big enough to become a frog. So that's a little bit of a disadvantage of that. All right, we're going to talk about the amniote egg at the beginning of our next lecture.